Okay, this is the next part, the last video in this section, dividing radicals. We did dividing radicals before, but we really kind of did them easily where we had a monomial in our denominator. In this particular instance, we're going to have a binomial in our denominator, okay? And we either might have a monomial up top, or we might have a binomial up top. And we need to what we call rationalizing. Okay, we talked about this in the last video. It's in the previous section. We talked about rationalizing denominators. This instance, we're going to be what we use called conjugate. We talked about conjugates in previous sections as well. Usually we referred to them with the letter I. So remember we had 2 plus 3i, and the conjugate was 2 minus 3i. We did also talk about square roots a little bit. We talked about, say, 2 plus root 7, and the conjugate of that was 2 minus root 7. Remember, the only thing that we flip are these numbers here. We don't flip anything else. Okay, so if it was 3 minus 3 root 3, then the conjugate would be 3 plus 3 root 3. Okay, again, this sign is the only one that flips. Everything else does not. Now let's get into some problems. All right, these first two. Remember, I don't like denominators that have roots. We've talked about that previously. So I need to multiply top and bottom by its conjugate. So its conjugate is root 3 minus 3 root 2. Root 3 minus 3 root 2. So here's what happens. Let's do the top first because that's easy. So if I do the top, I distribute, I get 5 root 3 minus 15 root 2. That's easy. Now let's do the bottom. You can very well do the box. Okay, very well. So root 3, 3 root 2, root 3, negative 3 root 2. So this is 3. This becomes a 3 root 6. This becomes a negative 3 root 6. And then the last box becomes a negative 9 times 2 is negative 18. How do we do that? Well, because I did the conjugate, remember the middle term cancels. It's not there anymore. So 3 minus 18 is negative 15. So my denominator is negative 15. So let's all put this together. 5 root 3 minus 15 root 2 over negative 15. Well, can I reduce them? Can I divide those by something, and can I divide those by something? If you look, they're all divisible by a negative 5. I can pull the negative out, and they're all divisible by that, right? Because I'm dividing by a negative 5, this gives me a negative root 3, because 5 divided by negative 5 is negative 1, plus 3, because negative 15 divided by negative 5 is 3, root 2 over negative 15 divided by negative 5 is a 3. So that's your answer there. That's called conjugation, multiplying by the conjugate. Okay, we don't want square roots in our denominator, therefore you have to multiply to get rid of it. Let's go to 14 here. Conjugate of 2 plus root 3. Hopefully you know that. It's 2 minus root 3. Distribute. 6 minus 3 root 3 under, well actually that's over, isn't it? Over. And remember there was a shortcut that I said. You can multiply the two first numbers. That's 4 minus, and what's root 3 times root 3? That's 3, so that's a 1. So 6 minus 3 root 3 over 1, which is 6 minus 3 root 3. That's our final answer there. If you write the 1 underneath, you're not right because it can be simplified. So you got to simplify it. So this is your right answer right there in the box. All right, let's do these two last examples here, and in this video we'll call it a day. Multiply by the conjugate. 3 plus 5 root 3, top and bottom. Ooh, messed up. The bottom. Remember we talked about shortcut. 3 times 3 is 9. Minus 5 times 5 is 25. Times 3 is 75. So that's negative 66. If you want to do a box with the denominators, put them in a box. You very well can. Your middle terms are going to cancel, which is your diagonal, and then you're going to get negative 66. Okay? The shortcut is to do what I just did. All right, and I'll do the shortcut on 20 as well. There isn't a shortcut on the top because they're not the exact same, just the plus or minus difference. They're different, right? So let's do a box. So we get 3 root 5 negative root 3, 3, and then 5 root 3. All right, here we go. This is 9 root 5, negative 3 root 3, 15 root 15, and negative 5 times 3, which is negative 15. All right, so my numerator. If you notice, I can't actually combine anything because this is a root 5, root 15, root 3, and that's no root there, so I can't combine anything. So we're just going to rewrite it. 9 root 5 minus 3 root 3 plus 15 root 15 minus 15. Done. Can't reduce anything. I'm done. Oh, am I? Oh, I'm actually not done. Uh-oh. I can divide all of these by 3. So my answer is 3 root 5 minus root 3 plus 5 root 15 minus 5. Under, divided by 3, is a negative 22. Now, if you want to be more specific, I don't like negatives in my denominator, so this negative can pop up. And when it pops up, it just changes the signs of all the numerators. So I get negative 3 root 5 plus root 3 minus 5 root 15 plus 5 over 22 positive. I will accept the one with the negative in the denominator. It doesn't look right. This one's more proper, but that one's still okay. Now let's go to this one here. Conjugate. 2 minus root 5. 2 minus root 5. Shortcut. 2 times 2 is 4 minus root 5 times root 5 is just 5 equals a negative 1. So my denominator is negative 1. Numerator. Negative 3 minus root 3. 2 minus root 5. Negative 6 minus 2 root 3. Positive 3 root 5 and positive root 15. So I can't combine anything from the box, so let's rewrite it. Negative 6 minus 2 root 3 plus 3 root 5 plus root 15. That is one answer. Remember on the previous problem I talked about having a negative in the denominator. Technically this one should be reduced because it's just a negative 1. So the full incorrect answer is going to be a positive 6 plus 2 root 3 minus 3 root 5 minus root 15. Because it's a negative, I have to flip all the signs in the numerator. And then that 1 just disappears. Okay? That concludes this video. Again, go back and watch it if you need help with dividing, with rationalizing denominators, multiplying by conjugates. All right? Ask for help, do questions, be successful.